присоединились к этой сессии. Меня зовут Александр Турилин.
Hi, I'm Alexander Turin. I'm Education Director of Digital October. I'd like to give you our friend, Charlie Harrington here, and he's with Knewton. By the way, this is the first time that Knewton comes to Russia. I'm certain this is a name you know, because indeed it's a legendary company. In fact, Knewton was the first company to start applying big data to education. I'm certain Charlie is going to tell you himself everything there is to know about these technologies. So please listen carefully. He's indeed talking about the future of education. And this future is already packaged into some Knewton products. And they make education smarter, and these guys know how to process the huge amount of data that education usually generates. So let's welcome Charlie. And he's about to say his presentation now.
Thank you very much. I just learned how to read my name in Russian, and I can assure you, if you've been paying close attention to the agenda, I will not be speaking for the next 2 hours. So just want to let you know that this will be a little bit shorter than that. My name is Charlie Harrington. It's a pleasure to be here. This is my first time in Moscow. I've been here a week. I've managed to successfully traverse on the metro to get here today. So it's been a great trip, and I'm happy to be here today to tell you a little bit more about Knewton, what adaptive learning means. I'll show you an example of an application of adaptive learning in the classroom, and then I'll also tell you a little bit about how the technology behind Knewton's big data recommendation engine actually works. This is my first time using a clicker, so let's see how this goes. Okay, great. So a little bit of a motivation behind Knewton as a company. So here I've plotted access to basic education over time. This was in fact one of the first projects I was tasked with when I joined Knewton. Our CEO said, can you make me a chart of access to education over time since the dawn of man? It seemed like a reasonable thing to be able to do. But it's centered around 3 major revolutions that were technological revolutions that dramatically increased access to educational content. Each of these revolutions, from the academy to the printing press to the advent of compulsory education, shifted the way that information was able to be accessed and got basically those folks who had previously been underserved populations the ability to learn at a higher level. And it had dramatic runoff effects in the rest of society. We believe that we are now at another revolution, the advent of online education. That's what this conference is all about for the last 2 days. So what online education means is that those folks who have previously been unable to get educational content can. And this here is a motto that we say quite a bit at Knewton, that the internet really only does 2 things. And those 2 things are distribution and data mining. Now, in that combination, the internet over the last 10 years has had a tremendous impact on almost every other information-based industry. By that, I mean an industry where it can be reduced to zeros and ones. So you've seen tremendous impact of content getting to places it's never before been possible. And you've also seen in your daily lives the impact of personalization. When you go to most websites, whether they're news or games or shopping, those websites are adapting to you. They're responding to what you like, what you know, who your friends are, and presenting you with content that is curated based on those things. So those 2 things together really have changed the way that we interact with information media-based industries. And we would say now that the internet is having its impact on education. So a number of companies are focused on this first problem, this first opportunity that the internet gives, distribution. Yesterday, there were a number of folks from some of the MOOC providers, edX, Coursera, Khan Academy, and a number of the publishers are actually present today. These folks are making educational content available to underserved populations in a way that it's never before been possible. This is an incredible thing, in combination with changes to infrastructure, mobile phones, tablets, we believe that the world's population will have access to education that really has never before been possible, which is incredible. Now, Knewton's tackling this second opportunity, this second challenge, data mining. Given that the access is now there, there's an opportunity for those who are offering educational content to do exactly what's happened in shopping or watching movies or listening to music, creating a personalized experience. When you make that transition from print to digital, as education is going through right now, you basically will be missing the mark if you simply put a textbook online. A flat, one-size-fits-all textbook doesn't take into effect the powers that data mining can bring. What Knewton is trying to do is tackle this problem. What we want to present is a world where digital learning materials are curated based on your strengths, your weaknesses, what you like, and what keeps you ticking. The most important thing that we want to do is help students learn more effectively and more efficiently. And that's the opportunity that Knewton has been tackling. Now, there's a particular reason that educational content, we believe, is incredibly ripe for data mining. And this is very different from data mining in other industries. So there's massive amounts of data in education. This data has always existed. It's just never before been capturable. Students are learning constantly in classrooms. They're interacting with content when they go home, when they're doing their homework. And imagine a student going through a homework exercise and they're struggling through different steps. They might have tried different tactics. They might have referred back to a previous chapter's learning material. That information was always there, and that presents important insights into how that student learns that could be useful for the teacher or could be useful for the next day's lecture. Well, previously, that wasn't instrumentable. That wasn't capturable. But digital materials mean that in the world of the internet, in the world of online education, every single interaction of a student has with learning content can be tracked and can be used to help us understand how that student thinks and be used to make the next session a little bit more effective. What this technology can do is effectively offer a one-to-one tutor. Imagine if your textbook was as responsive as a one-to-one tutor. And so there's massive amounts of this data. The second thing that makes our data scientists at Knewton very excited is that the chunks of content are very granular. The things that matter in an educational world are not the textbook or the course or even the chapter. What they are the individual concepts. And those concepts, the third point here, if this works, oh well, I was trying to use the laser pointer, it didn't work. Those chunks of content are incredibly highly correlated to each other. That has a tremendous impact on our ability to do things like proficiency estimation. This concept has been around for decades. Standardized tests are based on these same principles. So because educational content is very granular and they're very highly correlated, a student can take an exam like the SAT in the US and sit down for 3 hours, and we can have a pretty good estimate of their understanding of high school mathematics. And that's been around for decades, and research and statistics around that have given us very good indications that you can use this to make meaningful predictions about what students know and what they understand. But it's never before been possible with a student's textbook or with every interaction that they have with learning content. So for those three reasons, we believe that education is incredibly ripe for data mining, for personalization. So that's our mission. Our mission at Knewton is to bring personalized learning to the world. And we've created an open platform that anyone with educational content can use to provide that personalized learning experience. It's tremendously difficult to create an infrastructure that can be continuously adaptive. Later in the presentation, I'll explain to you what it means to be continuously adaptive. But what we're looking at on an ongoing basis is an estimate, a model of what each student understands, what each student's strengths are, what their weaknesses are, and then using that to provide a number of features in our partners' digital learning applications. Those things are content recommendations. Those things are teacher dashboards and analytics. And those things are empowering teachers with the ability to make their classroom more effective. And what I'll do later is show you some examples of how this technology has been used in real classrooms in the United States and around the world. I guess the other point to make here is that just a background around the company, Knewton is 6 years old. We were founded in 2008. And at this, when I joined the company, we were about 30 people, largely teachers and software engineers. And over the past 3 years, we've transformed into a 200-person company. We recently opened a London office, and I'll tell you a little bit more about that. And we're establishing partnerships with publishers all over the world. Many publishers, many companies, universities and schools are thinking about taking content online, and Knewton wants to be in a place where we can be part of that dialogue. Now, a common question that we get is, what types of content can personalized learning impact? Mathematics is a fairly obvious one, and in fact, we started in mathematics. But at this point, Knewton is powering over 6 million people on our platform in a variety of different subjects: math, physics, French language learning. English language teaching happens to be one of our more popular subject domains. When I explain technically how Knewton works in a bit, I think it'd be interesting to think about how this could be applied to different subject areas. Now, this is from a recent blog post just to highlight the need for personalized learning technology. It's fairly obvious, when a teacher comes into a classroom, students have a variety of different educational backgrounds. They have different contexts in which they're coming to learn that day's lesson. And the notion of a one-size-fits-all curriculum really doesn't make sense given all of these different things. Students have different motivational styles, engagement styles. They might even have different goals or deadlines. These sort of things are variable by each individual in a given class. So what our technology is trying to do is come up with a way to harness that individuality. So this is a list of some of the features that our partner products have incorporated. The top here is a recommendation engine. So what Knewton can do is present a textbook that has been curated for you every single day, every single time you log in. What you're seeing, that stream of content, both questions, videos, text, is curated based on what we believe right now to be the very best thing for you. Another thing that we can do is provide insight for teachers into how their students are performing. Not simply their answers to questions, but actual predictions. We have one feature where we call it readiness forecast. A teacher can set a goal for the class, and what we can do is take a prediction. Based on everything we've learned about this student right now, we will predict whether or not they are on or off track to meet that deadline. Now, a teacher can choose to ignore that, or a teacher can tailor their lesson based on that feedback. They can drill into those students who are off track and give them extra feedback in the classroom session. So all these tools are trying to do is just empower the teacher, the parent, the learner themselves with a little bit more insight into what's actually going on as students are learning. And this is, again, just illustrating that feedback. If a textbook, if your workbook can be more responsive, if it can help make your time in the classroom more engaging, then teachers can be opened up for a lot of the more interesting activities that they've always really wanted to do. So cross-disciplinary activities, metacognitive exercises, these are things that if an engine, a textbook, can take care of the more rote, mechanical bits of learning, then teachers can be opened up for a lot more interesting classroom uses. Okay, so this is a visual that we created to explain where Knewton fits into the educational ecosystem. So it might be difficult to see with the chairs, but all Knewton is a behind-the-scenes data layer. We are integrated with our partners' learning applications. Again, who are our partners? These are textbook publishers, learning companies, universities, anyone who's offering digital education content. Now, they've got a platform, maybe it's an app, maybe it's an online course, and then they've got a front-end experience that the students and teachers are interacting with, and really Knewton is just behind the scenes. The learner, the teacher, never even has to know that they're using Knewton's technology. They just know that they're using a much more responsive, personalized digital application. Okay, so this next bit, I wanted to show you what this might look like. given all this context around the benefits of the system, I wanted to show you an example of adaptive learning in reality. So what I'll show you is an application that we developed in conjunction with Arizona State University. Arizona State University, if you're following ed tech and you're looking for innovative ed tech companies, they're typically associated with Arizona State. It's a large public institution in Arizona in the United States, and they've set up basically an innovation lab where in their online courses, they've allowed themselves the flexibility to incorporate interesting technology. So they were a perfect partner for us. When we started the company, we originally went to the publishers and said, we'd love to incorporate this into your digital textbooks. And this was in 2007. And most of the publishers said, we're barely getting digital right now. We think you're way too early. And we were trying to say to them, no, the time to think about this is right now. But this was pre-iPad coming out. This was 2000, 2008, and digital really hadn't clicked with them. So what we did was we went direct to consumer. In fact, Knewton is still often known as a GMAT company in the US for the business school test prep exam. We needed to show the publishers, the potential partners, how this technology could impact students. Following our direct-to-consumer route, the next thing we did was create a institutional product. So we partnered with Arizona State University to solve a problem. And this problem, it was incredibly well suited for technology like Knewton's. So effectively what they had was a situation where students were admitted to the school, but they failed their introductory math diagnostic test. They were perfectly fine on every other standard for the university, but they couldn't place into freshman year mathematics. Now, this was a big problem for Arizona State University. It was also a big problem for the students. The current solution that they had was to send those students to a local community college where they'd have to take a full 6 months remediation course in lower level mathematics. This was a tremendously difficult experience. Many of the students actually had to physically take several buses to different campuses. And for those students who only needed a little bit of extra help, maybe 12th grade mathematics, well, they were still stuck taking the full year's course. And the statistics around this course were actually very poor. There was a high number of students withdrawing, and then those students, if they withdrew this course, there was an incredible correlation with those students actually dropping out of the whole school. So tons of lost tuition for the university, but more importantly, this was a terrible experience for the students. And that's where we saw an opportunity to come in and help them in working with their curriculum developers to create an online course that was adaptive, that responded to exactly what each student needed. And we developed a learning application, and you can see what it looked like to the student in the course of 6 months. And this was brand new content that we developed with Arizona State University and a very engaging front-end experience. What I'll show you, this is really the last product that Knewton ever built. This, again, was a showcase of our technology. And the way this worked is that students logged in either fully online or blended classrooms with a teacher in a computer lab, and what they were given was a personalized curriculum, where when they logged into the system, the thing that they needed to do was just hit this "Let's Go" button. That is Knewton's recommendation. So what we're doing is we've basically mapped all of the educational concepts in developmental mathematics from 6th grade up to 12th grade. We've created this big scaffold of all the possible paths that a student might need to take in order to be proficient enough to enter that first year course. And it's an incredibly engaging UI. There's notions of that on or off track indicator I told you about. There's gamification. And the idea behind a lot of that was we wanted to do anything we could to keep that student motivated. These are students who were already struggling, and the longer they stayed on the system using these metrics and analytics, the more opportunities Knewton had to figure out exactly what bit of content they needed to have that aha moment. I finally get it. I'm ready to move on. So it was a very simple product, one goal, get through the content as quickly as you could. This is what one of the bits of content looked like. In an interactive video with a teacher teaching a bit of content. And then that was followed by a number of questions. And what Knewton would do is every time the student hits the Let's Go button, we'd figure out exactly what that student needed. It might be a test, it might be some practice problems, it might be a remedial video. And the student had a very simple flow through this course. Hit the Let's Go button, follow the next Knewton recommendation. And what we did was allow those students to accelerate their learning. If you showed strong proficiency, some students were able to actually finish this course in a matter of hours. Others took weeks, and most took about 2 to 3 months. And what we did was we basically allowed the student to see where their strengths and weaknesses were. Of course, the teacher had access to this as well. But what we did was we said, if these little apples here indicated to the student that at this moment in time, we determined that you're proficient in these concepts. These are your strengths. And then you could move on to later, more difficult concepts. Now, if we found later on that you actually were missing something here, we would, of course, send you back. It's a much more dynamic system than simply saying, go through this gate, then do this, then do this. We really thought about it as a continuous system. So if you move on to something later, something more difficult in 11th grade, but we think that you need something back from 8th grade, we of course want to make that content available. It's a very different way of thinking about designing an educational product. And it's something that we're talking to a lot of publishers about, de-siloing their content from fixed titles or fixed grade levels, opening up your portfolio, letting all of your great content be available when it's needed. So that's what we did in this product. Now this is a visualization of what that knowledge map looked like. We call it a knowledge graph, and I couldn't even show the whole extent of this. But effectively what this was grades 6 through 12 mathematics. Maybe you've heard about the Common Core state standards in the US. And we used those as the scaffold for creating this map, and then we created content specific for it. Now, in any Knewton-powered product, there is a knowledge graph at the back end of that. That knowledge graph, and I'll explain this in the next section, is a hypothesis. Based on the way the content's written, these are what subject matter experts working with Knewton's data scientists believe all the possible relationships through that content might be. Now, these are just hypotheses. What we do is use the data to determine the most effective paths, figure out which of these relationships is strong, which is weak, and over time this map will evolve. But being a machine learning data science company, it's really useful to have this as a seed. This is our initial corpus for where the engine can take over. So we created one of these for developmental math, and this really doesn't want to work. So basically, this is a concept, solving math problems with all 4 operations. And what this map means is it's a collection of prerequisite edges. If you're working on this, the system expects and assumes that you've mastered mathematical operations with addition and subtraction, and mathematical operations with multiplication and division. It's basically a prerequisite map. What's interesting, though, is that this content, these videos, these questions, might be in a very different chapter from the content over here. These maps are cross-cutting. They're cross-cutting across standard taxonomies or textbooks, but they're really, really valuable. And so we don't actually display this to the student. I think a student or teacher would be horrified if they had to see this giant graph. But what we'll do is, you remember the simple let's go, all the student has to think about is following this recommendation. And we'll provide justification, work on this because you just mastered this concept. We want to establish trust in this system while at the same time giving Knewton's engine the flexibility to figure out that dynamic path through content, which is going to be individual for each student. Okay, so this is a map that we did using all the data in the course. This is that same knowledge graph, simplified a bit. Each of the darker areas represented a concept. And the lines, the web, are all the different paths that students took through that map. And what you can do with this is overlay an individual student's path. This is effectively their learning fingerprint. I really wanted to have this as a t-shirt that each student got when they completed the course, that no one else thought that was a good idea, but I think it's an interesting way of thinking about learning paths. And certainly when we looked at each of the students' paths, it was clear that no one student learned in the same way. Now, I don't know if this is possible to play this video. AV team, hello? Is there someone in charge? Yeah, okay. So it's fine, we can send a link around to this, but this is that same data set visualized in a different way, and I think it's pretty cool. That's not it. Yeah, it's at the bottom, just click watch now. Let's go. Okay, I'll start explaining it as he does this. So it's that same knowledge map. The colors are the different subjects. So here, these are statistics and probability in green. You've got functions over there in white. Again, this is that same developmental math content. The easier is up here, the more difficult is down here. And these little dots, these little fleas, those are the students. We don't really call them fleas, but it kind of looks like that when it starts going. And inside each of the concepts are the bits of content. So videos, questions, etc. And what you're going to see, hopefully, is a time lapse of each student's path through that course. This, I think, was about 500 or 600 students going through that math product. I guess this is not going to happen. Oh, yeah. Okay. All right, so the semester has started. It is September 5th. Now students are logging in. Now this is a collection. We just tracked all the data that was going on as students were following that Let's Go button. And it was incredible what we saw. Students are truly learning in different paths. But there's also, it's not just the paths, it's the speed. I don't know if you can see this guy up here. That guy needs some help. He's going all the way back to the beginning. I think that's even like, how does this product work? It's like the intro video. So the speed is because he hasn't logged in a while either. So that's exactly when you have to give an alert to a teacher. The other thing to think about, okay, it's December 5th. I'm a teacher, I have to teach a classroom. My students are literally everywhere. How am I possibly going to have a classroom that makes sense? So that gave us a lot of insight and then led us to create, I got to go back to the presentation. Yeah, cool. This is on our website if you want to look at it. Okay, so that led us to realize, okay, we need to evolve the product to include tools for teachers to harness what's going on. Sure, we can let a textbook or a learning application give students recommendations, but that's not enough. You need to be able to use the data, use the analytics to present insights to those who can intervene in the learning process. A digital textbook will never be enough. You need the teacher to come in and help. So this is the teacher's dashboard. So this is what we call the 5-minute view of what's going on. Obviously, you guys saw, there's tons of data. There's tons of data behind this. But we wanted to give a simple, actionable report to teachers to let them manage their classroom time. So you could imagine a professor 5 minutes before class logging in and then seeing a dashboard where she can see that 2 students are complete, 78 are on pace to finish, and 15 are off track. And if the teacher clicks into that, she can see a list that will allow her to filter and drill down and diagnose exactly what's going on with those 15 students. So that was an interesting bit of feedback that we got. And I think that's a really important part of, or opportunity for digital learning. When you put something out there in the market, you need to be with a partner who can be responsive and give you that feedback. So Arizona State told us we needed better tools for our teachers. And so this is one thing that we did. Obviously here we also have some other alerts, intervention opportunities. Hopefully here is where the teacher would have seen that that one student is going all the way back to the beginning. And then what a teacher could do, I mentioned she could drill down. So here I've clicked into John Doe's profile. And what this shows is John Doe's completion. Now he's on track to complete the course on time, which is great. He's got 3 out of 5 subjects mastered. But if John comes to the teacher and asks for extra help, we've presented some places where John's still struggling. Actually, it looks like on factors and multiples, he's tried twice to do the diagnostic test out, and he's only gotten a 40%. So despite the fact that John is on pace to finish the course, just simply looking at that, you might think that he's doing okay. There's still an opportunity to intervene and help that student learn. And that's one of the things that we think you can unlock when you use big data to change the way your online courses work. Okay, so this is cool too. So after we rolled out that course for 1 semester, the teachers said, that's not enough. I need more. I want to be able to, when you saw all the students in different directions, can you help me group those into logical groups for my classroom time? So what we did was we created, using our analytics, a study group generator that in real time, when you click this, it will group students together based on their strengths and weaknesses. So a teacher can put the classroom into a number of different small groups and give that group personal instruction. And then what they asked for, and I think this is indicative of the way this technology works, teachers will keep asking for things if you're giving them what they want. Then they asked, can you create these groups so that Brad has mastered the concept, and then Jody and Tom have not, but they learn the same way, where Brad could be doing peer-to-peer instruction. So again, that's something that we worked on with them. So I think that when you have a good partner, when you're working in a digital application, instead of publishing a textbook that sits on the shelf for 6 years, you can have a very responsive, flexible product that is constantly changing and adapting to those needs. So this was a tremendous success for Arizona State University. Here are some stats. So I remember I told you about the problems that they had with students dropping out. In just 1 semester, we even saw these results where pass rates jumped up to 78%. There was a 47% reduction in students dropping out. And one of the things that I think was most great about this was that 50% of the students were finishing at least 2 months early, which meant that they could go on to take that first-year course. So we thought these were fantastic results. We saw similar results at other large universities around the country. And that is really, for us, was a sign that this technology was ready to go again to publishers and try and put this in every digital learning application. So this is important, I think, in terms of why someone like Arizona State University endeavored on this project. So not only did they see incredible results for their students, they used this data to rethink the way that they were structuring their classroom. A lot of schools and universities are trying the flipped classroom and blended classroom. So what ASU did was looked at the results. They had several different classes trying this product at the same time with different success levels. So what they wanted to do was figure out those classes that had the most students succeed, what was different about those classes? Did they have more laboratory time? Were there additional tutors? Were there creative discussions and projects? So data like this not only can be used to drill down into students, but it actually can be rolled up for administrators to understand how to better utilize online and blended learning. Here's something that is pretty interesting. The way Knewton works is every time we get a student interaction, that gives us more information about that student. But it also gives us more information about the content. And what we can do with Knewton's engine is take every single student interaction and compare it to future success. And that means that we can make predictions about statistical properties of questions and videos. Are these questions doing a good job of predicting future success? And after a course goes through, we can then go back to the publisher or to Arizona State and say, you need to replace this video. It's not doing a good job teaching. Or these questions are really, really great, and you should write more like this. So it's a much more virtuous cycle of creating content. And when you look at the data and make these predictions, you can make that publishing process for the school or the education company much more efficient and effective. This is that same point I made. We basically were able to track completion rates for each individual student over time, and then think about changing policies. And there was one policy probably worth mentioning around competency-based learning, where schools often had problems assigning credit if students were finishing several months early. So they had to find a way to still attribute credit even though the seat time wasn't meeting the state mandated regulations. So I think that seat time requirements and things like that are things that we need to think a little bit more flexibly about if you're going to move to competency-based learning. Okay, so I was asked to talk a little bit about the technology behind Knewton, how this works. So this next section is actually something that I'm on the business development team. If I'm talking to a publisher or an ed tech company about how Knewton works, I will walk through this next section. So this section explains all the things that Knewton needs to understand in order to provide recommendations and analytics. Okay, we call this the exclamation point slide, because you can see it gets narrow and there's a little dot down there. So these three things are the main factors that go into Knewton's information. The first is that knowledge graph. We work with the publisher to create a knowledge graph for every single product that gets launched on our system. This knowledge graph, to reiterate, is a mechanical representation of the concepts in that content. This graph is specific for each body of content, and we work hand in hand with our publishers to create a good hypothesis about all these possible paths. The next thing that we need to understand is the data that we can receive from these products. Students answering questions, students watching videos, working with online simulations or labs. What is the bit of data we can get about interactions with that content in the graph? And that's going to be individually tied to unique students. And then the final thing is what we call goal management. What we want to understand, having created this map of the content, is what is that student or group of students' specific learning goals? This might be tied to linear assignments in a course. It might be an end-of-course exam. In the previous product we looked at, there was one goal: complete the content as quickly as possible. And then you saw Knewton basically take over. You saw the recommendations going in a lot of different directions. Well, actually, in a standard primary classroom, it is going to be much more structured and linear in terms of what the assignments are. You might have to finish chapters at the ends of different weeks. You're likely going to have exams. Well, that is important information for Knewton to understand. That helps us optimize what area of the graph we're focused on. And then finally, once we understand all of those things, we can give a personalized recommendation directly to that student. So this is, I'll walk through a little bit more slowly. So this is what a traditional textbook hierarchy might look like. Chapter, section, learning objectives. Section, learning objectives. Very linear. This is a very good way for search and index, but it's not good for adaptive learning. So this is what we do with something like that. Now this is you saw what a real graph looks like. This is a small sample graph. We will take those learning objectives and create this hypothesis of all the relationships. Now here, adjectives and adverbs, I've indicated that there are some strong prerequisites to parts of speech and nouns and a weak prerequisite to verbs. What we'll do is use this to have that scaffold for recommendations to start testing the strength and weaknesses of these things. And again, what's interesting is this might be in chapter 7, this might be back in chapter 2. In a standard layout, you might not know that that connection is there. In fact, this might be in one book, and this could be in an entirely other book or online title. So what we've seen is that a lot of publishers who are building new content are just, instead of creating graphs for each individual title, will create it for their whole portfolio and make that content available when it's needed. So that's something that we're seeing, and I think a lot of the innovative publishers are thinking about content in a different way because of a representation like this. Okay, the next bit, the data. So here is a pretty simple multiple choice question. So when a student answers this, all Knewton needs to receive is a little broadcast of what they did. So this is just a snippet of some of the data we would be sent, what they answered, what content asset it was, how long it took, what their score was, did they get it right, did they complete it. So this is pretty basic data. This is probably already being stored by most online learning applications, and all Knewton requires is that to be broadcast to us. And then finally here on goal management, I'll say something else here. What's cool about this is each time this comes through, it basically creates a ripple through the graph. So you got this right, and you're working on this. Well, that means that we can start to infer or predict that you're ready for this concept. But if you go down here and you start to struggle, well, we might send you all the way back to that. So each interaction that we get is a ripple through the whole graph. That's how the graph starts to change. And then every other student going through the same graph gives us more data. Okay, here I've given a interface that shows a student perhaps setting learning goals for themselves. Now, a teacher could do this. A student might say, I want to master long division by Friday. A teacher might say, classroom, you need to be ready to take a chapter test on equations and expressions in 2 weeks. Okay, great. Well, Knewton wants to know that. So here, the bit of data that we would get is, here's your goal, adding single-digit numbers. The target date is here. We want you to have a 75% proficiency. And then here, we let the teacher say, I want to make the entire content available. Or a teacher might say something like, I want my students to be ready for single-digit numbers, but I don't want them to go past chapter 5. We want to give that flexibility to each individual instructor and teacher to constrain or use as much of this system as they want. And the great part about it is they don't have to learn a new system. Knewton is just being plugged into the systems they're already using every day. Teachers have grade books, teachers create assignments. All Knewton needs is just to get a little bit of information out of that. And so then finally, once we have all this information, we can start to run through our algorithms to predict the very best content for that student. So we're looking at that student's engagement levels. What types of content has that student, when they've interacted with, stayed on the system a little bit longer? Perhaps they're doing better when they see a bunch of practice problems before they go into their core instruction. Well, that's something that Knewton needs to think about. Instructional value. How much does our system predict that by showing this individual piece of content, the student will learn? So we'll assign a value to each bit of content for its instructional value. We'll also look at assessment. This is where Knewton's kind of hungry to understand, if I show this, do I think I'll learn more about that student's knowledge state? And then again, target scoring, criticality, those things relate to urgency. Now, a student might be weak in one area of the course, but they have a test tomorrow on this concept. Well, then we better highly weight that when we're thinking about this ranking of the content. And I've listed here some of the different things that we're looking at, our algorithms are looking at when they make these recommendations. On the content side, we're thinking about the difficulty of the question, which we're computing through the data, how engaged it would keep them. On the learner side, whether or not we think they need remediation, their pace, have they repeated material or not. On the goal side, what's upcoming, when is it due? So there's a number of factors that we're thinking about. These things can't be predicted in advance. That graph is not a fixed flow through a course. It's not saying, if you get 3 out of 5, go this way. If you get 2 out of 5, go that way. It's just a scaffold. And then we use all this data to dynamically change what's going on. Here, a video, when we're scoring content, a video might be highly engaging, or it might be low engaging, but it might have high instruction. A learner might need remediation back in the graph, but they've got a test on something tomorrow. So again, these things can't be predicted in advance. Your textbook, while being a sound pedagogical way through content, can't think about all these things. These things differ in each individual classroom, each individual learner. And you need a system that is dynamic to be able to capture and use that effectively. And so very simply, what we send back to our partner products is a recommendation. All this is a ranked list of the best content to work on right now. Now, a publisher, an application developer can use that in a lot of different ways. We've seen tons of different things, which is great. Knewton, at this point in our company's history, we're just a platform. We're just a data layer. use our technology the way that you think your students want to see it. So you could imagine a product like the math product that I showed you, where the student is led completely by Knewton. Every single activity is simply the top recommendation. In other cases, we've seen partners want to use us in a tutoring role, where students will go through a course in a fairly linear way, but on the side they have this adaptive tutor that at any time they can jump over and they might see a ranked list of the best things they need. You know, we're seeing a lot of different ways to use this, but very simply this top thing might be to watch this video or do a question. And I mentioned as well the teacher reports. A lot of those factors that we're looking at, how urgent things are, how engaged things are, well, that's valuable data to be showing to a student, a parent, or a teacher. So we'll send data back that can power things like this report here. So here, there's homework due May 5th. Right now, Knewton's predicting that 50% of the class will not complete that on time. The teacher never before had that level of insight, or at least not, her textbook didn't have that. She might have known that intrinsically, but now the textbook can show that. And the teacher can come in and drill down into the students who have low expected scores and help them. Okay, so what the Knewton API provides is a toolkit. Use it in a lot of different ways. Make content recommendations, present insights about students, and then, most interestingly, have a learning history about that student as they go through your course. What we basically provide is a profile that stays with a student as they move from publisher to publisher or title to title. When you move from grade 3 to 4, our system learns a lot about you in grade 3. Well, wouldn't it be great if that information was available to your 4th grade teacher? When you're connected with a system like this, you can effectively warm start when you begin that next year's coursework. Okay, so this next section, I just wanted to talk a bit about what partners are doing with this kind of technology. So these are some of the folks we're working with. Because we're just an API, we can power all kinds of educational content in all languages. I've been over in Europe for a year now. We've established a number of partnerships with folks here in Europe, which has been very exciting. But we also have a presence now in Latin America and Asia. And really, as I said, that transition to digital is happening. And what we want to do is be in a place to help those folks who are making that transition harness the data that can be generated for better student outcomes. So, if this were, oh, how do I do this? Okay. So I want to show you one example product that's been built. This is what a textbook can look like when you're using Knewton. This was developed by a company called Triumph Learning. They are a US K-12 primary company. And what they were doing for the last 10 years was basically making PDF worksheets for the No Child Left Behind testing. They had a really good business, but it was all print, and I think they saw what was coming. So they came to us and said, I need to disrupt myself and create a digital learning application that's entirely online, that's entirely personalized, and uses recommendations to create a personalized experience. So they built this from scratch, really fun, engaging UI. You've got Cloudy over here that is using Knewton's analytics to track your progress. You can earn flying pigs. And for Knewton, this is fantastic. Originally we thought about actually being the front-end interface and saying to publishers, just give us your content and we'll render it. Well, we never could have predicted this. This flexibility is something that we always want to be able to accommodate. And all we are is this behind the scenes. The user never knows they're using Knewton. They just are using an incredible learning product. So here, instead of that one big goal I showed you, the teacher for this student has set 5 goals. They have different due dates. You can see how far along you are towards completing them. And when a student clicks into this, what Knewton will do is pick the best activities for them to work on to meet their goal. And here's what it looks like to a teacher. So the teacher, Ms. Sabornak, can look into her classroom, see all the different goals she's set, and then drop in a bunch of different data and metrics about their students' progress. So here she's looking at what are students struggling on? Where are the areas where students need the most help? And that gets just layered over this representation of the different goals. I think this is a really cool way of looking at the way goals can relate to each other. So this is clearly not linear, and it's very flexible and lets the teacher have that same dashboard, that same before classroom understanding of where are students stuck, where are they struggling, and where are they excelling. I think this technology is not just for students who are falling behind, but if a teacher can identify that students are doing really well, then you can give them more advanced work. So that was really important for this product. And then the same sort of drilling down into an individual profile. Here we're looking at Francisco's proficiency for the different assignments. This is not only what we've observed, but this is what we're predicting about Francisco's future performance. Really valuable data now available to teachers. It's a different way of administering a classroom. Here's another product. Houghton Mifflin is using this right now for mathematics. And this is a similar representation of an assignment, a readiness forecast. Here's a data point we can provide. Right now, based on everything we've observed, we predict that your students will get an expected average score of 93%. Now, if you drill down into an individual student, you can see that student's predicted score. So again, the product is being used in a lot of different ways. It's been really effective in facilitating classrooms. I think almost all of our products have teachers at the center of how to harness this kind of data. I think that's really, really important. And in light of what we've been talking about at this conference, we believe that big data and personalized learning can really help that transformation, particularly for teachers. And then the final point I'll make is around content efficacy. So the data that Knewton's looking at, as I said, is much more granular than comparing book to book, the way an Amazon recommendation engine might work. We're looking at the concepts within the book and how those things are related. And what we want to do is set up a system where textbooks are things that are as dynamically updated as a website, where you can A/B test content, figure out what's working, and fix it immediately. We think that that's the way publishing is heading, and a system like Knewton can really help that by tying content directly with student outcomes. Well, thank you all very much. I can stick around for some questions.
Charlie, thank you very much for the very powerful presentation. Now we can come to the question side. And I have a question first, so I'll use this opportunity. You were speaking about the knowledge graph. Yep. So is there, and referring to the last slide, is there a way not only to understand where a student is and how is the best way to move forward through the course? Is there a way to kind of update this graph through machine learning?
Yeah, as I said, I'm sorry if that wasn't clear, the graph is just an initial hypothesis. It's what the subject matter expert, the publisher, and Knewton believe those relationships to be. We will use the data to update that graph. What we might find is that in certain areas, the content runs out. Students need more content. These are the concepts that are struggling. We might also find that the relationships don't exist, or that there's a missing concept between those relationships. And the way we do that is by looking at every student's interactions and figuring out, when they went this route, did that lead to future success? And so the graph will dynamically update throughout the length of a course. We're going to be getting strength and weaknesses of the different relationships. We're going to be getting things like difficulty of each individual question. So that's constantly being updated during the course. And then what we'll do is, when a course is over, we'll say to the publisher, here's a list of the areas where you can improve that graph and improve that content. We think that that is really powerful, and honestly, when I talk to publishers, that's one of the areas that we spend a lot of time on, because they think that a dynamically updated map can be something that can make content publishing more efficient, more effective, save money.
Thank you very much.
Жданов Roman, BitClass. Charlie, thank you very much for the great presentation. My question is how developers of online courses can benefit from data that you already collected. Is it possible to analyze, to look at the data that you collected from other courses?
So that's a great question. what we're going to make available very soon is the ability to access data in the student's learning profile. So the first thing that will happen is the ability for a student to log in and see their learning history with every single Knewton-powered product they've interacted with. We've talked to some developers about being able to harness that and pull that into their own application. And that's something that I think over the next 12 months will be available via the API. And certainly, you know, from the start, when a student logs into a course, they also are logging into their Knewton profile. So if you're developing an application with us and you have students who've used the system, it's already making available the data that we've learned about that individual student's learning style, their engagement style. So that's already being reflected every time you create a new application.
Thank you for great, brilliant presentation and product. I represent one of Russia's large system integrators, and I'd like to know what is your business model, and
sure.
do you offer franchising?
Sure. So, great question. I like it here, so I definitely want to come back. Knewton's business model is pretty simple. We partner. We're not a vendor. We are a long-term partner with each publisher that we work with. And what we do is we set up a relationship where we have a revenue share or a per student fee. And what that means is Knewton takes a small cut of whatever that textbook costs or that online course costs. And as the products grow more successful, both Knewton and the publisher have a strong financial return. You know, we really just want to be in a place where we can work with a publisher on every single learning application. And another important point is we're an open platform. We are working with all publishers, some of whom are direct competitors. And I think hopefully you saw that the technology can be used in so many different ways that that's fine. Publishers are building unique things with their unique content, and Knewton just wants to be this infrastructure that can power all of that. On the franchising side, we're looking for strong technology partners. In addition to partnering directly with publishers who have both content and applications, one thing that we're interested in is talking to folks who offer the technology platform but maybe not the content. If you have a system that is a learning management system that other publishers put content onto, well, you can integrate with Knewton and then make it easier for those folks to work with us and have a mutual relationship. So we've done that a couple times in the past, and we're definitely looking for more of those. So we'd be happy to chat about that if that's relevant.
Есть еще для одного вопроса время?
We got time for one more question.
For your product as software as a service, or like an engine, a framework?
It's a software as a service platform. So it's basically right now a private API that our partners will be able to access. And you know, the business model is based on usage and registrations. So it's set up to be a software as a service business.
И давайте еще один вопрос.
Yeah. Hi. I was just wondering if you, obviously you're a commercial product, would you be open to working with nonprofits, including nonprofits here in Russia? We are not planning on monetizing, you know, the project that we're working on. So how would that fit into your model?
That's a great question. We are very committed to working with all educational players. And one of the reasons that we set up as a commercial enterprise is to be able to have enough funding to work with nonprofits. We often say that we have a double bottom line policy. And one of the first things that we want to do, even in the US, is find a way to work with free content and make that available. So we're very interested in working with nonprofit enterprises, and we've been approached by several, and I would love to discuss a way to make that happen.
Окей, все, самый последний вопрос.
And this will be the last question indeed.
Indigos.com founder. We run an aggregator of about 5,000 applications for K-12, and I've been following your product for few years now, and it's really a wonderful product and an idea. I wanted to see, I wanted to understand how difficult, how resourceful, how much resources, money, time, and so on, does a publisher need to integrate with with you, and how does it work in a new market, new language like Russian?
Sure.
How much additional resources you need for
Yeah, yeah. So we're trying to make it as easy as possible to work with us. Right now, there's definitely some hurdles that you have to get through to make an integration work. We need to create that map of your content. So that means that we need your content to be easily machine readable. So that's one thing. The other thing is the technical integration. Frankly, the technical integration is pretty easy. It can be done in as little as a week to make the systems talk to each other. Typical integration takes about 3 to 6 months. And when they get longer, that's because publishers are building new content. They're writing new content. They're working with technology companies to create the UI and the UX. But I would say an average project takes about 3 to 6 months from starting the relationship to getting it launched. And Knewton works very hard to make this as easy as possible. And what we do, one of the reasons we actually opened this office here, is because when you sign on with Knewton, we assign an integration architect to work hand in hand with each company. So we're working with your subject matter experts, we're working with your developers, we're making that as simple and as easy as possible. In a new market, the API allows us to work with content from multiple languages. We're already powering products in many other languages other than English. And in terms of creating the knowledge map, that's one area where we do tend to hire folks who can speak different languages to validate the creation of those maps. So we've actually recently hired someone who speaks Russian, but of course we are always looking for new people who are interested in working with us and can help accelerate that process.
Thank you very much, Charlie, and big round of applause for Knewton.
Thank you.